All right, folks, here is a lesson on how to complete the square, which is a quadratic formula alternative. And just like with the quadratic formula, we use completing the square in order to find the x-intercepts. Okay, when we have a quadratic function that is in this form right here, or that looks like this. So what you see on the screen over here are 3 levels out of 4 levels of completing the square. Let's start with the top left over here. Okay, let's zoom in a bit. First step is we're going to isolate the x's by adding 7 to both sides, and this is what we get over here, okay? The second and most important step, which is the key to completing the square, is we take the term that has just the x to the power of invisible 1, okay, which is this term right here. We're going to take the coefficient, we're going to multiply it by a half, okay, and then square it. So 8 times a half is 4. Square it, you get 16, and we're going to add 16 here. And if we add 16 to the left side, we also have to add 16 to the right side, okay? Um, so step 2 is the key step to completing the square. And from here on out, it's mainly algebra. We're going to factor, okay, this blue to get to this blue over here, okay? I'll link a separate video in the description on how to factor this to this, okay? But just to give you the quick and easy version of it, if this was 25, if this were positive 25 and this were positive 10, then this would be plus 5 plus 5. If this were to be plus 25 and minus 10, this would be minus 5 minus 5. Okay, so since this is plus 16 and plus 8, the square root of 16 is 4 and 4. And because this is positive, that's going to be plus and plus. Okay, and then of course, we're going to combine 7 plus 16 to equal to 23. Okay, for step 4, if you ignore the square roots, okay, and just focus on the black, that is what I get after combining these two into x plus 4 squared, okay? So this is what we have so far, okay, in black, and we're going to get rid of this squared by doing the inverse function, which is square root, okay? And if you square root on one side, you have to square root the other, okay? And recall that square roots and squares cancel each other out. So we're essentially left with x plus 4 on the left side. And on the right side, okay, it's going to produce a plus minus sign, okay? Um, and finally, we're going to move the 4 over. We're going to minus 4 to both sides. So I could put the minus 4 here, but I chose to put it over here, okay? And this is the same answer as you would get for quadratic formula. Okay, so let's do a quick recap on this. The first step is to isolate the x's by adding 7 to both sides. Second step is to take the term with the x to the power invisible 1, which is this term right here. Take the coefficient, multiply it by half, then square it. 8 multiplied by half is 4. Square it is 16. Add 16 here on the left side, which means you have to add 16 on the right side. Factor the blue to become x plus 4, x plus 4. And then we add 7 and 16 and we get 23. X plus 4 and x plus 4 combined to, or x plus 4 times x plus 4 combined to x plus 4 squared. We undo this square by square rooting, and what you square root on the left, you have to square root on the right. And this produces a plus minus scenario, okay? And we're left with x plus 4 on the left side, to which afterwards you just subtract 4 from both sides, and I just put it on the left side of the plus minus sign, of the plus minus root 23, just so your answer can look like what you would get on the quadratic formula. So this is a level 2 out of 4 completing the square problem where you see a coefficient in front of the x squared. So a, which is this pink, okay, is greater than 1. Previously, okay, over here, a was equal to 1, okay, and now a is going to be greater than 1, in this case 4. Okay, so again, this is a level 2 completing the square problem, a level 2 out of 4. Okay, so let's see how we approach this problem over here. Okay, the first thing I'm going to do is same as example 1. I'm going to isolate the x's. Okay, so just like in example 1, I add 7 to both sides. I'm going to do the same over here. Okay, I'm going to add 7 to both sides. Okay, and then I'm also going to do a partial GCF. Okay, or let me just say I'm going to do a GCF. I'm going to GCF the 4 and 24, and the greatest common factor of 4 and 24 is a 4. Okay, and the way you check whether or not you did the GCF correctly is you distribute the GCF to see if you get the original problem. Okay, and 4 times x squared is 4x squared, and 4 times 6x is 24x. So yes, I did the GCF correctly. Now, previously I said it was a partial GCF because a true GCF would mean that you also GCF an x out here because uh, both these terms have an x in common. Okay. However, in this case, you only GCF out the coefficient. Okay, you ignore the variables. Okay, so we only GCF out a 4 in this case. Okay, and just an FYI, if this said 6, then we would GCF out a 6. Okay, if this said 8, we would GCF out an 8. Okay, so I GCF out the 4, and next step is similar to what we did earlier, is the core of completing the square problems where you half then square the term that has an x to the power of 1. Okay, so this is a term that has x to the power of 1. It's 6. Okay, 6x, I mean. So we take 6, multiply it by half, and you get 3. Square that, and you get 9. Okay, so I'm adding 9 on the left side, to which you may think and say, well, I'm going to add 9 to the right side also. But you don't. You're adding 36 to the right side because on the left side, even though it looks like you're only adding 9, you're truly adding 36, okay, because of this 4 on the outside of the parentheses. So you got to distribute the 4 to the 9 to see what you're really adding on the left side, which is 36. Okay, so if you add 36 on the left side, you have to add 36 on the right side. Okay, now we're going to combine 7 plus 36 to equal to 43. We're going to rewrite this blue into x plus 3, which becomes x plus 3 squared. Okay, I should have said x plus 3 times x plus 3 here invisibly, and that becomes x plus 3 squared. And next step, okay, I'm going to divide both sides by 4, and I get 43 over 4. Okay, and then x plus 3 squared. So I only focus on the black print here. And then afterwards, I'm going to square root I'm going to square root this side to undo the squared. Okay, and if I square root on this side, I have to square root the other side. And on the right side, the square root, the square root of this produces a plus minus scenario. And then here we successfully canceled out the squared and isolated x plus 3. And then lastly, subtract 3. Recapping on example 2, we start off exactly the same way. And by the way, remember, example 2 only differs from example 1 because we have a coefficient in front over here. Okay, your a is greater than 1. Okay, so we're going to add 7 to both sides and we get to here. We're going to GCF a 4 out of these two terms and we get something that looks like this. Okay, we're going to take the term with the x to the power invisible 1 and we get this. Okay, and we take the 6, multiply it by half, we get 3 squared is 9. So we add 9 here, but really we're not adding 9 on the left side, we're adding 36 because you have to distribute the 4 to the 9. So if you add 36 on the left, you have to add 36 on the right. Okay, 7 plus 36 is 43. This right here factors to x plus 3 times x plus 3, which combine to x plus 3 squared, okay? And then from here on out, it's just algebra. Divide both sides by 4, and I get this line in black. Square root both sides, and I get a plus minus scenario, okay? And the squares cancel with the square root. And then lastly, subtract 3, okay? All right, in the next example, which is level 3 out of 4, we are gonna return this back to an invisible one, and this number is gonna be an odd number. Here's the level 3 out of 4, okay? Um, we can see here, let's see if I can include as much of the previous examples as possible. Okay, so in level 3 out of 4, you can see this is invisible 1 for the coefficient A, and this is an odd number for the coefficient B. Okay, so let's go ahead and get started over here. The first thing we're going to do, okay, is add 7 to both sides. Okay, and then we are going to half 9 or multiply 9 by half, and we're going to keep it as a fraction and then square it. And we're going to get 9 squared is 81 as a numerator. 2 squared is 4 as a denominator. And we are going to add this 81 over 4 to the left side, which means we have to add 81 over 4 to the right side. Okay? So again, um, we take this 9 over here, half it, and we get 9 over 2. Square top and bottom, we get 81 over 4, which is what we add on the left side. And we also have to add 81 over 4 on the right side. Okay, next step is using Algebra 1 techniques to combine these. Okay, so 7 can be rewritten as 28 over 4 because 28 divided by 4 is 7. Okay, and we want it with a denominator of 4 because we want to combine it with this fraction that also has a denominator of 4. Okay, so now 7 becomes 28 over 4, 81 over 4 carries downwards. I combine the numerators by adding, and 28 plus 81 is 109, and then keep the denominators the same, okay, because when you add fractions, the denominator remains the same. And so these two combined to 109 over 4 by this process here, okay? And now, how do I get from top blue, okay? How do I get from top blue over here to bottom blue, okay? Well, I'm going to square root 81, which is 9, square root 4, which is 2, okay? Just like over here, I square root 16, the big 16, and I get 4 and 4. I have to square root the 81 and square root the 4 because this is a fraction to get 9 and 2, okay? And because this is a plus, this is plus and plus. If this were minus, this would be minus and minus, okay? And now, next step, I rewrite, okay? I combine these blues to become x plus 9 over 2 squared, okay? And so this step becomes this step in black, okay? Ignore the red square roots. We're not there yet, okay? And now I square root both sides, okay? From here on out, it's just algebra. I square root both sides so that the square root and the square can cancel because I want to get rid of the square and eventually isolate x. And just like the previous examples, um, after square rooting both sides, the square root and the square cancel, and uh, the square disappears, and we get a plus minus scenario on the right side. And the last step, okay, is to subtract 9 over 2 to both sides. Again, I move this, instead of putting the minus 9 over 2 here, I put it over here so that we can see a match with what we will get in our quadratic formula. Okay, so this would be the same answer as a quadratic formula. Now, let's do a recap on level 3 out of 4. As you can see, the only difference between level 3 out of 4 and level 1 out of 4 is that in level 1 out of 4, we have a even number for your b value, okay? And here we have an odd number for your b value, which is the coefficient right before the x to the power invisible 1. So we start off the same way by adding 7 to both sides. Afterwards, we take that b value, multiply it by half, we get 9 over 2, square it, which means you square top and bottom, and you get 81 over 4, which is what you add here. Once you add on the left side, you got to add on the right. And then we have to combine these two by converting 7 into 28 over 4 so that the denominators match with the 81 over 4. Okay? 28 plus 81 is 109. And remember, when you add fractions, you keep the denominator the same. 109 over 4 is what these two become. Okay, so we can see it becomes 109 over 4. We take the square root of 81 over 4 and we get 9 over 2 under the same logic that we took the square root of 16 and got 4. And because this is plus and plus. If this were minus, you get minus and minus. We rewrite this blue into x plus 9 over 2 squared. 109 over 4 gets carried down. Square root both sides, okay? And the square root and the square cancel, and the square root of the right side produces a plus minus, okay? And so now we're left with this, and then you just subtract 9 over 2 from both sides. All right, folks, we've made it. We are doing completing the square level 4. How level 4 differs from level 2. Okay, well, let's start with what they have in common. There is we have a value in level 2 and level 4 that is greater than 1. Okay, and in level 2, after GCFing, when we get to this step, the b value is a nice clean whole number, okay? Whereas in level 4, after GCFing, okay, we have a nasty looking fraction, okay? That is the main difference, okay? So let's start from the top with level 4. Now, this is your original function in for a level 4 type problem. The first thing we're going to do is the same thing we've always been doing, which is we're going to get the x's by itself by adding a 7 to both sides. Okay? So, that's how we get to this second line over here. And now here we are going to GCF out a 3, okay, from here. So when you GCF out a 3, okay, from this term, it becomes x squared. And when you GCF a 3 out of here, it becomes 11 over 3. And like I said in the previous video, if you want to check your answer of whether you GCF correctly, you can distribute the GCF to see if you get the original problem here, okay, or the original expression. So 3 times x squared is 3x squared. That checks out. 3 times 11 over 3 gives you 11 because the 3's cancel out when you multiply 3 by 11 over 3. Okay, now we get to the heart and soul of the problem, okay, um, uh, which is halving then squaring. So I'm going to take the term associated with the coefficient associated with x to the power of invisible 1, which is 11 over 3, multiply it by half and square it. 11 over 3 multiplied by half gives you 11 over 6. And when you square 11 over 6, you got to square the top and bottom. 11 squared is 121. 6 squared is 36. So I'm going to add 121 over 36 over here. Okay. Again, do not add 121 over 36 on the right side, okay? Because remember, we're not really adding 121 over 36 on the left side. We're adding 3 times 121 over 36. And 3 times 121 over 36 is going to be 363 over 36 because you multiply 3 by the 121 over 121, okay? You can also think of 3 as 3 over 1 and multiply the numerator, which is 3 times 121 to give you 363. And invisible 1 times 36 gives you the 36. Okay? And then I think that's the hardest part. Now it's just a whole bunch of algebra, combining fractions and simplifying. Okay, so let's look at step 3. Okay, and let's start easy. Okay, how do we get from this blue in parentheses to these parentheses here? Okay, well, again, we're going to square root this. Okay, square root this 121 over 36, and square root of 121 is 11. Square root of 36 is 6, and because it's a plus and plus. If this were a minus, that would be minus minus. Okay, and then let's take a look on over to the right side over here. Okay, how we have to combine these. Okay, and so I want to rewrite 7 into a fraction with the denominator of 36 so I can combine it with this 363 over 36. So I rewrite 7 into 252 divided by 30 over 36. And we can check our answer we can check whether or not this truly equals to 7 by dividing top number by bottom number. And when we do that, we do indeed get 7. Okay, so 7 is rewritten into this fraction. We combine this fraction with the previous 363 over 36, and we get 615 over 36. Remember, when you add fractions, you keep the denominator the same. Okay, and 252 plus 363 gives you 615. So again, when I combine 7 plus 363 over 36, I get 615 over 36 through this process right here. Okay, now moving onwards. Okay, let's look at this line and everything besides the red. Okay, so I'm going to combine the x plus 11 over 6 into x plus 11 over 6 squared. I'm going to get rid of this 3 by multiplying by 1/3 to both sides. Okay, and then these 3's will cancel. All right, and let's see what we get in the next line. Okay, so again, these 3's cancel. Okay, and that's why the 3 disappeared here. And then I'm going to multiply these two. 615 times 1 is 615. 36 times 3 is 108. Let's see what we got down here. Okay. Now I'm going to square root both sides in red to get rid of this squared. So square root and the squares cancel. And the square root on this side produces a plus minus. And don't forget to subtract 11 over 6 to both sides. And again, you can write this negative 11 over 6 on the right side, but I choose to write it on the left side to match it up as closely as possible to the quadratic formula. Okay? And let's do a recap. Okay? We look at this function over here. Okay? First step is, as usual, we're going to isolate the x's by adding 7 to both sides. Okay, and then once we get here, I'm going to GCF a 3. Okay, and then I'm left with x squared plus 11 over 3. Okay, again, if you want to check your answer to GCF, just distribute it. Okay, and we indeed, after distributing this, we indeed get back to here. Okay, now I'm going to take this 11 over 3. Okay, look over here, and I'm going to multiply it by half and get 11 over 6, square it, and I get 121 over 36 here. But remember, we don't want to just add 121 over 36 here because I have to multiply it by the 3 that exists on the outside. So 3 times 121 over 36 gives us 363 over 36. Okay, and then going on to the next line, I rewrite this parentheses, okay, into x plus 11 over 6 as x plus 11 over 6. I combine these two, okay, first of all, by rewriting 7 into 256 over 36. And I combine these to become 615 over 36, which is right here. Okay, these two parentheses get combined together and we rewrite it as a squared. Okay, I get rid of this 3 by multiplying both sides by 1/3. Okay, and I'm left with this line in black, square root both sides to get rid of the square. This gets square rooting the right side produces a plus minus. And lastly, I subtract 11 over 6 to both sides. Okay, so there you have it, folks. That is level 4 of completing the square. Okay, I hope that made sense, and I'll link you in the next slide to a relevant video. I always want to end with this reminder. If you don't get math or any subject, keep searching for that right teacher. Keep searching for that right method. Remember, we live in an age of nearly endless learning resources, especially online. You don't have to assume math is not for you. And on that note, I wish you persistence and perseverance on your journey to learning anything.